Okay, get ready for this, because today we are talking about a technology that is straight out of a comic book: quantum sensors. Seriously, these things are giving us the power to see the unseen world that's right under our feet.
I mean, really think about that for a second. What if we could just peel back the layers of the Earth like an onion without ever picking up a shovel? Well, this isn't just a fantasy anymore. And that really gets to the heart of the problem, doesn't it? For pretty much all of human history, the only way we could explore this hidden world of geology and treasure and infrastructure was, well, to dig.
We're talking about everything, from ancient ruins and undiscovered mineral deposits, all the way to the critical water and gas pipes that our entire modern world depends on. It is all down there, completely invisible, and that presents both this huge problem and, frankly, an incredible opportunity.
So, how in the world do we unlock this hidden world? Well, the answer is what we're calling the quantum key. We're now able to use the, let's be honest, bizarre and wonderful rules of quantum mechanics to create a whole new kind of sight.
So what even is a quantum sensor? At its heart, it's a device that uses these wild quantum effects, like an atom being in multiple places at once, to become almost unbelievably sensitive. It can pick up on changes in its environment that are just way too small for any normal detector to even notice.
And that sensitivity is the secret sauce here. Imagine there's an empty space underground, say a cave or a tunnel. That void has slightly less mass than the solid rock around it, which means it has a slightly weaker gravitational pull. Now, you and I can't feel that difference, not at all, but a quantum sensor can. And that's how you start to build a map of the underground.
So how does this actually work in practice? Well, one of the main techniques is called atomic interferometry. Now, I know that sounds super complicated, but the idea behind it is actually pretty simple. First, you create this perfectly still, super chilled cloud of atoms. The best way to think of it is like a pristine, perfectly calm pool of water. Then, the tiny gravitational pull from something underground, maybe a dense chunk of ore, creates a teeny tiny ripple in that pool. And finally, you use lasers to measure that ripple with incredible precision. That little disturbance tells you exactly what's down there.
But this technology isn't just one single magic device. It's more like a whole toolbox of sensors. We have different kinds of quantum sensors designed for different jobs, and each one is specialized to see the underground in its own unique way.
For instance, you've got gravimeters. You can think of these as hypersensitive scales that literally weigh the gravity of what's below, which is perfect for spotting things like tunnels or big changes in soil density. Then you have magnetometers, basically a compass on steroids, which are amazing at pinpointing buried metal pipes or magnetic minerals. And then there's quantum radar, which sends out a signal to spot more general anomalies. You just pick the right tool for the job.
Now, of course, building these tools is not exactly simple. While the concept is really elegant, the engineering behind it is mind-blowingly complex. A typical system needs that quantum core, of course, but also high-precision lasers, vacuum chambers to keep the atoms from getting bumped around, and some really sophisticated software, often using AI, just to make sense of the incredibly faint signals that come back.
So that's the how. But now for the fun part, the wow factor, actually mapping the invisible. Let's look at the very real revolutions this quantum sight is going to power.
Just think about archaeology. For centuries, finding a lost city meant years of painstaking research followed by a whole lot of digging, which, ironically, can damage the very history you're trying to uncover. With this tech, you could map the foundations of an entire buried Roman villa right from the surface, completely non-invasively. It's a total game changer. And here's why this matters to you right now. All those rare earth minerals that power our smartphones, our laptops, the batteries in electric cars, they are incredibly hard to find. Quantum sensors could pinpoint new deposits with an accuracy we've never had before, which could genuinely make the transition to green energy a lot more achievable.
And really, the list of applications just goes on and on. Beyond archaeology and mining, cities could finally map their aging water pipes to prevent those catastrophic failures. The sensors could be used for surveillance to detect things like hidden tunnels. Some researchers even think they could help us monitor the subtle geological shifts that happen right before an earthquake. The potential impact is just staggering.
Okay, but let's be realistic. What about the road ahead? As with any revolutionary technology, the future looks incredibly bright, but you can bet there are some major obstacles to overcome first. It really is that classic case of promise versus problems. On the one hand, you have this absolutely unprecedented sensitivity and the ability to see without digging. But on the other hand, these sensors are so sensitive that they can be thrown off by what's called environmental noise.
We're talking something as simple as a truck driving by. They are also, as you can imagine, extremely expensive to build and operate, and they need really complex calibration to work correctly.
But even with all those challenges, the consensus is pretty clear. As one source puts it, this is a truly transformative technology. This isn't just a small improvement on old methods. It is a fundamentally new way of seeing and interacting with the world right beneath our feet.
And that leaves us with one last fascinating question. Once this technology matures and becomes widespread, and we truly have the power to see the invisible, what's the first great mystery we should solve? The lost tomb of a forgotten king? A new source of clean energy? The possibilities are truly endless.